Good afternoon everyone, welcome to the channel. In today's video I want to explain how to implement support vector machine using Scikit-Learn. This is also a supervised learning algorithm which can be used for classification task. So let's get started. I need to import the libraries as usual. So at first I need NumPy, then pandas from 𝐦𝐿𝐴.py. Then I need SVM, label encoder. Then from SVM model selection, let's import trend test split. SVC, which is a support vector classifier. And finally, from Scikit-Learn, import matrix. Okay, so these are my required libraries. Then I need to load mushroomsdataset, which I will use for today's example. You can find this dataset in the GitHub repository. This is a CSV file. So mushrooms.csv. Okay. So I'm only showing 5 rows and it has 23 columns, but all the columns are not appearing here. Looks like. Let's check the columns. So kill size, kill color, then stock shape, stock surface below ring. So it looks like 3 columns. These 3 columns are not appearing. Okay, let's write another line for showing all the columns. Next columns, there is no limit. Okay, now I think all the columns are appearing. Looks like all the columns are appearing. Let's check some information about this dataset. So it has 23 columns, starting from 0 to 22, 23 in total, and 8124 entries, and all are non-null. Okay, so there is no missing values, and the t type says object, so that means these values are all categorical. But we cannot work with categorical data in machine learning, so we need to replace them with numerical values. So let's check the shape. So 8124 as it shows here, and 23 columns of features. Sorry, not all our features. I think this is target. So 22 features, and one column contains the labels. Let's also check describe. So here we can see the unique values in each columns. Okay, so 2, 6, 4, 10. Okay. Let's check out the class. As it says, it has two values. One is P, another is E. So P means poisonous and E means edible. These are two types of mushrooms in this mushrooms dataset. Let's check the value counts. So 4,208 mushrooms are edible and 3,916 mushrooms are poisonous. So that's 8124 in total. Okay, let's number 3 perform preprocessing. I will use label encoder for converting the categorical values into numerical values. It transform. Okay, so let's check _head again. So now you can see we have on all the categorical values have been replaced by numbers. If you compare with this one, here we are seeing different letters, but here numbers. You can also come from here. So now you can see D type, which was previously object, is now showing integer 64. Let's separate features and labels. So features, I will call it X. So I am to drop two columns from it. One is called fail type. Class is obviously the target, and the labels will be the class column. So the reason for dropping fail type, if you look at it, so first look at it here, it says only one values, and after performing the processing, you can see this where is it, this P has been replaced with 0. So this will not have any impact on the model, so that's why I replaced it. I dropped it. Oh, sorry. Axis will be on to indicate that these are columns. Okay. Now let's split the data set. test size will be 0.3 and 0.7 is the train size. Random state 1. Oh, sorry. So, okay, now it's okay. Learn 𝘬𝘬𝗽𝗽 and learn 𝘬𝘬test. So 5,686 train samples and 2,438 test samples. As a result of 30-70 split for test and train respectively. Now let's apply our SVM. SVM SVM.fit xtrain and ytrain. Sorry, I forgot to change some parameters. Okay. Oh, forgot to put comma here. Yes. So finally the model has been trained. Let's check out accuracy of the test set. J is round. X test, Y test. Something is wrong. Why is this bracket showing here? Sorry, this would be finally. So we got an accuracy of 99.71%, which is quite good. Now plot confusion matrix. CM matrix confusion matrix Y test and ypred and disk matrix dot confusion matrix display CM display repos will be SVM dot process. Color bar box. The size will be 50. Int.x level is called prediction. Font size 15 and font weight bold. Then this will be available. Ground truth. That will be computational matrix. Something is wrong here. I think this will be capital. Okay. No, it doesn't fit entirely, but you can see. So there are 2438 samples in the test set. So it looks like all the zeros mean, let's see, so PE, so P is 1, E is 0, so zeros mean edible and 1 means poisonous. So out of 2438, 1236 are edibles and they have been predicted correctly because you can see 0 here, but that's not the case for poisonous. So out of 1202, 1195 have been predicted correctly and 7 has been wrongly predicted. Okay, we can also mention the names actually. So let's, instead of this 01, so categorical labels are label and poisonous. And just copy this. So now 0 and 1 have been replaced by edible and poisonous. Results are same obviously. Let's check few other metrics. So metrics dot accuracy score. We need to provide whitelist and update. So check session and recall. So this is same as this one, as this value, and precision is 1, recall 99.42%. So all the values are high. Then print classification report. So this is the classification report. We can see all the values are quite high, 99.1. So these are good outcomes. Finally, let's do a random prediction. So I have to copy this line. So random data. So we cannot use this since this is the target. And so we need to use cap shape, and we also cannot use this field type since we didn't use it during training. So I dropped it. So we have to choose from all the others. So it has 6 unique values. That means we can start from 0 and end on 5. That's true for all the others. So for this one we can start from 0 and choose any values between 0 to 11. So let's choose 2, 3, 9, 0, 8 on, 0, 1, 11, 0, 3, 2, 3, 8, 7, 3 to 4, 6, 4, 5. It should be 21. So 6, 12, 18, 21. Okay. Random data. Let's convert it into a data frame. Random data and columns. Okay, so these are the columns. But we need to remove this since this is not a feature, and also need to remove this one since we didn't use this one. Okay, let's organize it. Random data, and if random data equals to 0, then we know this is edible, else this will be poisonous. Just notice this. So see, 0 is P, 1 is E, and after performing this pre-processing, we see P is 1 and E is 0. So if this prediction is 0, then we will see edible. Okay, so we saw poisonous, that means the random rate must be 1. Yes, so it says 1. So in poisonous. So that's basically it. I used a mushroom dataset. You will be able to see this dataset in my GitHub, and this is a classification task. Okay, let's check the default values. So by default C is 1, but I changed it to 0.2. Kernel is RBF, but I used polynomial. Degree is by default 3. It only works when the kernel is poly. It doesn't work for other kernels. Gamma is by default scale. I used auto. Random state by default none, but I used 1. So I got accuracy of 99.7. Let's change it and see if we get what kind of values. So I changed auto into a scale, which is by default. Let's see how it does. Okay, so I think it reduced. It was 99 point something, then it became 96. So you can play around with these parameters, see how the classifier does. You can also check others. So now we have now 1236, 1195, 07. So after using this value, we are now seeing more wrong classifications. You can run the others as well. So now these values are also decreasing. It was 1 previously. Classification report. Now these values are also decreasing. So I think I do not need this anymore. Let's run this. Now we are seeing for these values, it's giving us edible, which is most probably a misclassification, since the accuracy is not as high as the previous one. So for better accuracy, I think auto is the right option. Now we get higher accuracy. Okay, so that's it for this video. Thanks for watching.